Hello world, this is Craig. Today's a short video about how to get going with an F8 assembler so that you can start writing code for this little MOSTEC 38P70 microcontroller that I used in this development board. This is just my setup. I'm sure there's others that work just as well, if not better. I'm using DASM, which is a general purpose assembler for a number of different microprocessor platforms. And I'll put a link to it to the GitHub home for this assembler. You can download executables for various operating systems. The version that I have is 20.14-1 and it's running on a 64-bit Windows. You download it as a zip file, unzip it, and you make a directory on your computer and you copy the unzipped files into that directory. There's going to be an executable file and then another folder that has information for the various platforms. And you'll want to look at the channel F folder, and there's a README file in that you can go through and read it. Once those are copied, you probably want to include in the path this assembler so that you don't have to go fishing for it each time or specify its full path name. There's many online resources to adding a path, but here's the 30-second version. In the folder with the DASM executable itself, right-click the path, select copy address as text, then right-click the Windows icon on your taskbar, select Settings, select About, scroll down, select Advanced System Settings, select Environment Variables, select Path and the user variables, click Edit, New, and then you paste in that path name. Save and OK your way out of all of these windows until you get everything closed. Okay, so now no matter which folder you're in, it'll find the assembler. So here back in the folder where you're writing your code, you can see here I use the AF8 extension for my assembly source code. Now you need to open a command window in this folder, and you can do that by holding the Shift key and right-click the mouse and then select Open Command Window here. You can use the PowerShell here if you're into that. The manual for the DASM is available, and you want to read through that, but this is the command that I use to assemble. So it's going to be DASM, my source file confidence.af8. The switches are -F3, -O, and then my output file name, -L, and my list file name. Now in PowerShell, you would need to put the --%. So you'd want DASM confidence.af8 --% and then the rest of it. DASM, of course, invokes the program. The source file is confidence AF8. The F3 switch tells the assembler don't screw around with the output binary file. Just give a raw binary file starting at 0 like 99% of the world is expecting. And there's more information on the F switch in the DASM manual, but the default is to slip in a 2-byte origin or starting address, which will lead to great confusion if you try to run a program where everything is going to be 2 bytes off on all of your jumps and calls. Now DASM distinguishes between upper and lowercase in the switches. So if you use an uppercase F, it's for defining a symbol. The lowercase f is for the format of the binary file. So you got to make sure that you keep your upper and lowercase correct when you're using DASM. Now that output is going to be a straight binary file. The little o is for the output file. Again, lowercase o. The lowercase l is for the list file. And then the file name. Notice there's no spaces between any of these switches and the file names. You can have spaces in file names, but you need to surround it with quotes or precede the space with a backslash, I think. The list file is, of course, extremely useful since it's the source file plus the program line number, the program counter, and all the mnemonics converted to opcodes, as well as the operands, addresses, and so forth. So the list file is going to be what you're using when you're debugging your code and you want to know exactly where all of this stuff is in your EPROM or your RAM or wherever you're placing your code. Now you can use an uppercase to get the list file, but the uppercase L will give you a listing file that includes the code for each pass, while the lowercase l was just the final listing. So the uppercase L can really get to be a large file. Sometimes I'll also tack on the S file name to get the symbol table. And using uppercase S gives you strict syntax checking, so you want to use the lowercase s. Now rather than open the command window each time, I usually create a batch file. So just use Notepad, create a file that has the exact same command line as before, and it'll do everything for you. But there is one little bit of a problem if you just have that command in there, because it'll open and close the command window and you won't have time to see the results from the assembly, and if there were errors or if anything was unusual or whatever messages came off the assembler. So to solve this, you can put a pause in the batch file so it stays open until you close it. But nearly 100% of the time after it's assembled, I want to look through the list file. So I have an additional command in my batch file that's just the list file name. In the folder where I have the code, now I've just got to click on the batch file and everything is done for me. And since I have the .lst extension associated with Notepad, the command window will just open the list file using Notepad, just as if I had clicked on that file name. And it not only opens the list file, but it leaves the command window open so I can see any messages from the assembler. Then when the list file is closed, the command window that had the DASM command line and the assembly messages will also close. And I find that very convenient, since the command window closes when closing the list file and it just leaves the desktop very clean. Now what I've discovered is that with DASM, it's useful to browse the list file to make sure the assembler actually did its job correctly. And this is important because DASM is not very robust. For example, if a relative jump is outside of the acceptable range, it won't throw up an error on the command line, but it will mention it at that jump location in the list file. Just a word of warning to go through your list file even if the assembler said there were no errors. Since DASM does several processors, you need to indicate the target platform, and that's done with the processor directive in your source code file. So not on the command line, it's not a switch, it's actually in your source code file. So at the beginning of your source code, you need to have this processor directive. You need to say processor F8. And this is a directive or a pseudo opcode, so it has to be tabbed in, or there has to be a little bit of white space before the processor. And there'll be no mistaking this if you forget, because rather than just give you one error that you forgot to indicate which processor, DASM will give you an unknown mnemonic error for each line of code. So you will notice if you forgot to put in the processor directive. All right, the output from DASM is just a binary file. In my setup, I send that file over to my EPROM programmer computer that has my Willem programmer connected on its parallel port. And I covered that Willem PCB6E programmer in another video. I highly recommend it for programming 2716s. It opens the binary file without any problems or complaints or errors, and it programs any version of the 2716 that I've tried. Since this code was orged at 0 and it's going to run at 0, there's no fancy offsets or moving in the binary required. But once it is open in the Willem buffer, it's worth looking at it to make sure that your code matches what you think it is and that you didn't forget the F3 switch or anything. And if you forgot the F3 switch, you'll see the first 2 bytes in the binary file are now the starting address in Little Indian. And remember, the F3 must be lowercase f, otherwise, at least according to the user's manual, you're specifying to define a symbol. However, I think that uppercase F to define a symbol has been changed, because in the command line syntax, it only has the D and M symbol definitions, not F. So maybe somebody can clarify that for me. And besides the quirks I've already mentioned, DASM has some annoying habits that are somewhat tempered by the fact that it was absolutely free. And I'm not a DASM super user for sure. Maybe there are ways around these. I'm only using it for my F8 code, and I'm just thankful enough to have the DASM that will assemble F8 code that I'm not going to complain unnecessarily. That said, one gripe is that it requires all org pseudo opcodes or directives to be in increasing addresses, which I find to be completely unnecessary annoyance. For example, I like to have my RAM reservations defined early along with my ROM reservations. And so most assemblers would just call out that, okay, this is going to be where that code segment goes. And then when you put it into ROM, that's just ignored because that's some other space besides what that ROM has. But DASM does not like this at all, and it gives an origin reverse index error. And there's no need for that. But because of this, your program needs to directly follow your memory map. And when you remap your memory, you'll need to reorder your program so that you don't get this origin reverse index error. Now, DASM does have some nice commenting options. You can do block commenting like you can in C. Another thing is you have to be very careful when you have DASM evaluate expressions, and you got to check the result by hand and carefully. Frequently, the result of an expression will be nothing like what you were expecting due to some little confusion it had when interpreting the expression. So that's just a word of warning to double check your expressions. There may be lots of trial and error involved until it's what you're expecting. As far as the rest of the sudo ops, I think they all worked as expected. At least the ones that I like to use include to bring in another file, the equals EQU. It didn't give me any surprises. Same for set. And as is common for most assemblers, the difference between EQU and set is that set can be reassigned later, where EQU will throw an error if you attempt to reassign that symbol again. The DC to declare data in the current address segment is a bit annoying. I think it literally follows the original F8 assembler in that it only allows 4 bytes to be declared. So if you have a message or something, it needs to be broken up into 4-byte bits. And normally you would use the DS directive to define the string, but since DS is an opcode for the F8, that had to be renamed to DC for the F8. And there's a section in the DASM manual for the different processors, so be sure to look at that section. It's section 13 for the F8. DB, on the other hand here, it let me put in 6 bytes, but unlike the 4-byte DCs up here, it didn't explicitly show the data bytes in the program counter. So that becomes inconvenient if you need to go back and look to see where that stuff is, because then you're counting on your fingers to figure out where those are. And I can't say that I trust this assembler enough to take its word that it put the correct bytes here. But I have used this, and then I checked the buffer in the programmer, and they are in fact there, and they're what they're expected. It's just a little bit inconvenient if you're going back and you're trying to find those by the address, because you don't actually have the address here. There's that. These other little things I talked about, maybe there's better ways of doing it, and if somebody can figure out how to intermingle my org directives without getting reverse origin errors, that's probably the most offensive limitation and the biggest complaint I have about the assembler. Well, except for the assembler not flagging relative jumps being out of range as an error, but I only needed to have my code not work once or twice before I started searching through the list file for those sorts of things. I think that's it. It's all the hints I have for getting up and running to assemble F8 code for this little 38P70 board. Eventually I'll get back to this code for the clock. In my code here you can see it was called a confidence test, but so far it's really only the clock program I showed you earlier. I've done a bit of rework, and I'm gradually adding my normal confidence test as I port that code over to the F8. So that's it for this video. Let me know in the comments if I missed anything useful, and if you have any of these answers for the things that bug me. Maybe it's not the problem of the DASM assembler after all. Let me know. I will talk with you later. Thanks for watching. Bye.